Welcome, everyone, to episode 1 of Beyond the Brush, The Art of Algorithm, a 4-part series discussing artificial intelligence's, otherwise known as AI's, impact within the art community. Any works referenced within this video can be found in the description below. Today's episode really focuses on the technicality and algorithmic work behind these image-generating AI. What does AI-generated art use? AI-generated art uses deep neural networks to synthesize images. These deep neural networks are artificial neural networks meant to mirror the way the human brain works. Kinda spooky, right? However, even among neural networks, there are multiple types of them. These include, but are not limited to, convolutional neural networks, known as CNNs, variational autoencoders, known as VAEs, and generative adversarial networks, known as GANs, and modern diffusion models such as Stable Diffusion and DALL-E 3. Convolutional neural networks, CNNs. This neural network, effective for image processing, works by taking features from given data, images, using convolutional layers. These convolutional layers are like filters or windows sliding across the given image. Classifications and analyses are then made to each portion of the images that have been filtered out. CNNs will progressively learn ranked representations of the input, often starting with the simplest parts, such as edges and textures, later combining them to recognize more complex patterns, such as objects. Variational autoencoders, VAEs. Variational autoencoders will try to compress an image into a smaller, more hidden representation, kind of like a summary. It will then rebuild the original image from said summary. The best way to describe it is like trying to repaint a painting after seeing only the thumbnail of the painting. This means that it's learning the essence of an image, and when asked to generate entirely new images based on input data, it can use said essence to make a recreation. General Adversarial Networks, GANs. Generative Adversarial Networks pair two networks, a generator that creates images from noise, and a discriminator that learns to tell real from fake. Training the two in competition leads to highly realistic images, as the repetitive process allows for the generator to improve with each iteration. Modern diffusion models. Lastly, we have modern diffusion models. Diffusion models are a type of generative model that create a new data by learning to reverse a process that gradually adds noise to data. They work first by corrupting training data with noise, known as forward diffusion, and then learning to reverse this process, known as reverse diffusion, to generate new data from random noise. For CNNs, they are highly accurate for images, efficient, flexible, and handle visual changes well. But they also demand big hardware and lots of data, can overfit, be hard to interpret, and vulnerable to trick inputs. For GNNs, they have sharp, detailed images, but can be unstable to train, and may struggle with fine-grained control. For VAEs, they smoothly mix between different internal codes and don't require a lot of computing power, but the resulting output usually looks soft or blurry rather than sharp. And lastly, for diffusion models, they require more energy to compute, but produce highly controllable, photorealistic, multilingual, prompt-driven imagery. Well, that was a doozy. In just years, AI art evolved from trippy CNN filters, remember those AI-generated artworks that looked like biblical horror, to text-prompted, near-photorealistic creations. But as well as any emerging technology, questions of legality and ethicality arise. Follow along with our next episode in the series, Beyond the Brush, The Art of Algorithm, where we discuss just how legal is your AI-generated art. Leave any comments down below and remember to like and subscribe. See you next time!